Geometry. This is our last section in this unit. I know it went by fast. We're just going to take all of the transformations that we've learned so far and throw them together. This is a combination of everything that we've talked about so far in this unit. So the composition of transformations is simply combining transformations you do to a shape. Combining transformations you do to a shape. We're going to do multiple transformations to a given pre-image. So this is a triangle is located at A, B, and C. So A is at -3, 1. Let's plot our pre-image. So -3, -1. There's our A. B is at -4, -5. 1, 2, 3, 4. -1, 2, 3, 4, 5. There's our B. And C is at -1, -5. 1, 2, 3, 4, 5. There's our C. We can connect A to B, and A to C, and B to C. So here's our triangle. So triangle is located at those, the vertices are located at those points. Find the image of the triangle after the transformations below. So looks like we're going to do a translation. Remember, this is the notation for a translation. We're simply moving all of the coordinates. Then reflect over the x-axis. Okay, so followed by a reflection. So we're going to do this transformation to all these points. And then the second transformation we're not going to do to the original points. We're going to do to our new points. So we're going to get a secondary image that's a transformation of the image we get after that first step. So first, x plus 10y. So we're going to move all of our x values 10 units to the right, and we're going to keep all the same y values. So a prime is going to be at, if I add 10 to -3, I get to 7. Keep the same y value. B prime, add 10 to -4 to get 6. Keep the same y value. And C prime, add 10 to -1 to get 9, keep the same y value. Graphically, this is just going to move all these points over 10 units. So if I am counting over 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And instead of having to refer back to these coordinates and plot each coordinate separately, I can make my life a little bit easier by knowing that my image after a translation should, oh, seeing that on there. There we go. The image after a translation should be the same orientation and shape that the pre-image was. So if B prime is here, then C prime is just going to be 4 units away. Those are 1, 2, 3 units away from B. 1, 2, 3 units away from B. And of course we can check, is this at 9, -5? And it is. And then our A, if I'm thinking about from where B is, it was up 4 and over 1. So there's our A prime. And we can verify that's at 7, -1. So whichever way you find easier to plot, if you'd rather plot it based on the position of the other points, you can do that, or you can plot it using the coordinates. So this shape, this is now going to get reflected over the x-axis. This is now going to get reflected over the x-axis. So so not the original. Our new point gets reflected over the x. Here's the x. And remember, in our transformation of reflecting over the x, it's going to keep all the same x values, but all the y values get made their opposite. So -y. So keep all those same x values. And the way we're going to indicate this, we're going to use, since it's a secondary image, we're going to use a secondary prime. So this is a double prime. So 7, we're going to make the y the opposite, so 7, +1. And B double prime keeps the same x value, makes the y value the opposite. C double prime keeps the same x value, makes the y value the opposite. The opposite of a negative is positive. So each of these get reflected over the x, so A prime is here. A double prime is going to be there. C prime here. If I count, it's down here at -5, so I'm going to count up 1, 2, 3, 4, 5 to get my C double prime. And my B, it's down here, 1, 2, 3, 4, 5. I'm going to count up 1, 2, 3, 4, 5. And connect the dots. To get our reflected image. So it got translated and then flipped, right? Slide and then flip. So we transform the transformation. Okay? Let's take a look at another one. We can do this with as many transformations as we need to. So triangle located at that same location. So let's start by plotting that. -3, -1. There's our A. B is at -4, -5. There's our B. And C is at -1, -5. There's our C. Connect the dots. There's our pre-image. There's our pre-image. This time we are going to start off with a 90-degree rotation counterclockwise about the origin. So rotating 90 degrees counterclockwise. So remember, the clock goes this way, counterclockwise, going to go this way. So we're going to rotate counterclockwise. Counterclockwise goes that way. So if I'm going counterclockwise, after a 90-degree rotation, all my points are going to end up one quadrant over. Okay, one quadrant over. But remember, for a rotation, we're going to exchange x and y. So this is the x, y. We're going to exchange x and y. And we're going to make one of them negative. Now, for me, the easiest way to remember which one I'm supposed to be making negative is to look at what quadrant I'm ending up at. So this one, I'm in the -x and -y. So when I rotate over, my y's are still negative. It's my x's that had to change. So what's now in this new x position will have to have the opposite sign. Okay, so this was at -3, -1. So now A prime is going to be at a +1, -3. Okay? +1, -3 for this A prime. Now remember, we can check to see if it's in the right spot by connecting the pre-image to the point of rotation and connecting the image with the point of rotation, and those should form a right angle. My B prime, switch x and y, make my new x value, change the sign on that. So it's going to be a +5, -4. So +5, -1, 2, 3, 4. There's my new B, my B prime, and my C prime at +5, -1. Switch x and y, make the x negative, or make the new, what's the new x? So +5, -1, there's my C prime. Connect the dots. Notice that that horizontal segment is now vertical. That's what we'll find when we rotate 90 degrees. Okay, so there's our rotation. Now we're going to, on our second step, take our image and slide it. Okay, so this we're going to add 3 and subtract 5. So move 3 to the right and 5 down. So my A double prime, adding 3 to 1, we get 4. Subtracting 5 from -3, we get -8. B double prime, adding 3 to 5, we get 8. Subtracting 5 from -4, we get -9. C double prime, adding 3 to 5, we get 8. Subtracting 5 from -1, we get -4. Oh, no, sorry, -6. -1 minus 5, -6. So A double prime at 4, -1, 2, 3, 4, 5, 6, 7, 8. There's A double prime. Remember, you can get there also just by moving 3 over and 5 down. So 3 over. So from A prime to get 1, 2, 3, and then down 1, 2, 3, 4, 5. We can do the same thing for B prime and for C prime. Over 1, 2, 3, and down 1, 2, 3, 4, 5. Over 1, 2, 3, down 1, 2, 3, 4, 5. So there's our B double prime and our C double prime. And we can double check that they're at the right spot. This is at 8, negative 9. This is at 8, negative 6. And it should have the same shape still. Remember, these are all congruence transformations. Should still have the same size and shape. It's just oriented differently from the original. And then finally, our last one, this is not a congruence transformation. This one is our only similarity transformation. K equals 2. We have to multiply each of these numbers by 2. And this is actually going to take us off of the page. So we won't plot this last one. We won't plot this last one. So we're going to still find the numbers though. So a triple prime, every transformation we do, we're going to add another prime symbol there. So multiplying by a scale factor of 2, we're going to take each of those numbers times 2. So 4 times 2 is 8. Negative 8 times 2 is negative 16. For B double prime, 8 times 2 is 16. Negative 9 times 2 is negative 18. And C double prime, 8 times 2 is 16, and negative 6 times 2 is negative 12. So yeah, some of these, or all of these won't fit on our, they're going to be way off of the thing here. But you can imagine from, when we dilate from the origin, it's going to scale everything up by a factor of 2. Not only is the figure getting twice as big, but the figure also gets twice as far away from the point of dilation. So maybe if we had a different point of dilation, we could blow it up in a different direction. But for now, it'll be enough to find where the coordinates would be. We won't plot the rest. So come ready to practice that in class next time, and I will see you then. Bye for now.